Good morning. Today we will be studying the chapter of chemical bonding in O-levels chemistry. So there are four types of chemical bonding: ionic bonding, covalent bonding, metallic bonding, and finally the bonding between alloys. So now firstly we'll be focusing on ionic bonding. What is ionic bonding? Ionic bonding is the bonding between two metals and non-metal atoms. So you have to remember that it is always between metal and non-metal atoms. Now, in order to understand the concept, we'll have to first understand that for an element, if each element wants to become stable, and how does it become stable? It becomes stable by either getting eight electrons in its outer shell. So for example, in this example, we have the example of sodium in this molecule. Now, as you can see, that sodium belongs to group 1 of the periodic table. This means that it has only one outer shell electron. So in order to become stable, if it lose how which is easier for it to lose one electron or gain seven electrons? Obviously, if it loses this outer one electron, it is more easier because it loses the outer shell and then it becomes stable. However, in the case of fluoride has seven outer shell electrons. So what is become easier for it? It is easier for it to gain one electron and thus become stable. So whenever you lose an electron, you get a positive charge as represented over here, and when you gain an electron, it shows a negative charge on it on the fluoride atom. So fluoride becomes stable, whereas sodium by gaining an electron, whereas sodium becomes stable by losing an electron. Now the number of electrons lost or gained by the two are the same because the lost one is gained by the fluoride atom. Now, the extremely important thing is to understand the types of forces which basically exist between ionic bonding. These types of forces are known as the electrostatic forces of attraction. These electrostatic forces of attraction are extremely strong, and these are responsible for the extremely high temperature which is required to break down the molecule and the high melting point as well. So this pretty much sums up the main chemical bonding aspect. Now we'll have to study the properties of ionic bonding. The most important property of ionic bonding is that they basically conduct electricity when they are in the molten or aqueous state. It is a repeated question that why don't they conduct electricity in the solid state? The reason is that in solid state they don't have freely moving electrons, whereas in molten state they have free moving electrons. Now, the property of free moving electrons isn't only applicable to ionic bonding, it is also applicable to other types of bonding, which I will show when we will study in the video ahead. So, as I have already told you, that they exist at high melting and boiling temperatures, and they are hard solids at room temperature. Now, in this example, I'll have to when writing the chemical formula of ionic compounds, the charge written over there +3 and -2, this is known as the subscript or superscript of the relevant ion. So when writing it in chemical formula, we basically cross out the charges. For example, the +3 goes over to the oxygen atom and the -2 goes to the aluminum ion. So it is written as Al2O3. Now we'll be talking about covalent bonding. Covalent bonding only occurs between two non-metal atoms. And non-metal atoms, for example, in this case, hydrogen. So there are two molecules of hydrogen. So hydrogen exists in group 1 of the periodic table, and thus it has one electron. So it loses one electron. And the important thing to know about the difference between ionic and covalent bonding is that the ionic bonding is the transfer of electrons, whereas covalent bonding is the sharing of electrons. They both share the electrons in this. Now, if I talk about the orbits, we know that an atom has in three orbits. In the first shell of the electron, it has only two electrons, whereas in the second and the third shell there are eight electrons. So hydrogen doesn't even have a complete first shell. So in order to get a complete first shell, it has to have two electrons in the complete first shell. So they both share these electrons, and thus the first shell is complete, and hydrogen has two outermost electrons, so it becomes stable. Now you need to know that the single dash represents the sharing of two electrons. This is very useful. For example, in carbon atom, this you can see two double bonds over here. So this represents that there has been sharing of four electrons simultaneously. So in this case, hydrogen and hydrogen share two atoms, and basically you should also know that whenever it is represented like you have studied sets, that the electrons are shown in the intersection because they are common to both of them. Similarly, the case with methane molecule. In methane molecule, carbon has four outer shell electrons, whereas hydrogen, there are four hydrogen atoms. So they all basically share one electron each, and in instant, so the carbon atom thus becomes stable by having eight electrons in total. Here you can see the number of electrons which are I've just shown over here. This is single bond, so there are two atoms here, two, 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 two. Total there are eight electrons which can be shown over here as well. Now the types of covalent structures, you need to know that the simple molecular structure consists of weak intermolecular forces, and this is responsible for the low weak melting and boiling points of the covalent molecules. Example of simple molecular structures include carbon dioxide, which is a weak gas, and oxygen gas bonding. Now we will study the giant molecular structure. Now there are several types of giant molecular structures. The properties of giant molecular structures is that they are often asked that why do they have extremely high melting and boiling points. The answer is that they have very high melting and boiling points because they have extremely strong covalent bonds. For example, you take the structure of diamond and graphite. So these are the properties of covalent bonds, and the extra important reason which I just discussed previously as well, that why don't they conduct electricity? They don't conduct electricity because they're insoluble in water and they don't have freely moving electrons. Now I come to allotropes. Allotropes are substances which exist in the same different, basically chemical state, although they are properties of the same carbon atom. For example, diamond and graphite are allotropes of each other. As you can see, the diamond has four carbon atoms bonded to each other, whereas in the case of graphite, if I show you that there are three carbon atoms which directly bond to each other, and it has a hexagonal structure. Now, the difference between diamond and graphite is that diamond does not conduct electricity, whereas graphite does conduct electricity. Why does it is why this is it? Because I explained to you that the diamond does not have freely moving electrons, whereas graphite does have freely moving electrons. And now the diamond is used for cutting materials because of its extremely hard nature, its insolubility in water. There are in the exam they ask you the physical and the chemical properties. So for example, diamond is extremely insoluble in water and it is very hard. These are, and it has a very high melting point. These are its physical basically properties. Now, if I talk to you about graphite, we need to know that graphite basically has freely moving electrons. This is the reason why it conducts electricity. Apart from it, you need to know the uses of graphite. For example, graphite is used in pencils. Why do we use it in pencils? Because the layers of atom basically slide over each other. This is the reason. These all of the answers which I'm telling you, these are basically answers to extremely important questions which are asked in the exam. Now, what is metallic bonding? Metallic bonding occurs between positive atoms and with the type of bonding which exists between only positive atoms and the surrounding sea of electrons or T localized electrons. Whenever they ask you the definition, you need to know the idea that the electrons are freely moving and they are basically moving in a random nature. Or although it might seem in this picture that they are in an order, in an ordered manner, but they are not. They are basically freely moving. The properties of metals are extremely important because they are freely moving electrons. Obviously, they conduct electricity, and they due to this, the metallic bonding became extremely strong and they have electrostatic forces of attraction. So there are extremely high melting and boiling points. Now, apart from this, metals are malleable and ductile. What does malleable mean? Malleable mean that their shape can be easily changed from one structure to another. For example, you hammer a metal and it will not shatter like a glass. A glass is a glass isn't a ductile substance. So glass simply breaks, but metals will not break. They will just change their shape. So the just drawing this diagram also comes in the exams. Now, what are alloys? Alloys, you need to know, are mixtures of metals and non-metals. And what the extremely important thing about them is that what makes them harder than metals. This combination of metals and non-metals makes them harder than metals because they have different sized atoms, and unlike metals which layers slide over each other, alloys prevent the layer because the sizes of the atoms are not compatible with each other. The layers of atoms are prevented from sliding over each other. Examples of main alloys you could remember are brass and bronze. Brass is a combination of copper and zinc, whereas bronze is a combination of copper and tin. I hope you liked the video and it clarified pretty much of your concepts. Thank you. I'll see you in the next video.